Let's look at a motion application with the LS Electric XGB PLC. For this example, we will be using a 3-axis motion system which utilizes many components offered at AutomationDirect.com. Our system is built on a sure-frame extruded aluminum base with casters. It utilizes IGUS dryland actuators and sure-motion couplers from Automation Direct attached to LS Electric gearboxes driven by L7P servo drives and motors. These drives are controlled by pulse train outputs from an XEM DN32HP 6-axis motion controller. For nearly any motion application, the very first step will be establishing a repeatable home position. The XGB PLC offers several ways to do this, so let's dive into the homing options. We have the XEM Motion Demo project file open in XG5000 and are connected with the XEM CPU. This file is available to download from the XGB Interactive Guide at AutomationDirect.com. Before we start working with the home function blocks in the XG5000 software, we need to configure the access properties in XGPM to execute the home functions that we want. Let's open XGPM from the XG5000 programming interface by going to Tools, Position Control. We can then open the XEM Motion Demo XGPM file. We will connect with the controller in XGPM as well. We will start with our access parameter data. To view the data, we go to the project window on the left side of the screen, expand number 1 axis data, and double-click on Parameter. This opens the New .Parameter window and displays the access parameters for all 6 axes in the controller. We are using axis 1 for our x-axis, axis 2 for our y-axis, and axis 3 for our z-axis. So these will be the 3 axes we will be concerned with configuring. We have already covered the general configuration parameters in another video, so we will just focus on the homing parameters. The key homing parameters have their own subsection. We can scroll down until we see Homing Parameter in the left side of the window. Home Position is the value that the axis position will be set to when a homing function is completed. The home high speed will be the more commonly used homing speed, and the home low speed will be used for 2-segment homing functions, such as moving to the over-travel limit sensor and then finding the home sensor. Home XL and decel times are the time in milliseconds it takes for the axis to reach full speed or full stop during a home movement. Home dwell time is used when the motion system has a small amount of system lag or mechanical deadband. At the end of any decel function, there may be a slight position drift even after pulses or motion have stopped being commanded. The home dwell time is used to allow the drivetrain to cease motion prior to home being completed. Home compensation is how many pulses the axis should move after it completes a homing function to position the axis for cycling. Homing restart time is how long the system will pause between the 2 segments in a 2-segment homing function. Home direction is the direction the motor should move for the initial homing search. Home method is where we can define the type of homing function we wish to use. There are 7 different options, each specific to a different application. Please review the product documentation and help files for timing charts and home method selection assistance. In our example, we will use the same settings for our 3 axes. Home position will be 0, home high speed and low speed are 150 and 50 pulses per second respectively. Home XL and decel times will both be 200 milliseconds. Home dwell time, compensation, and restart time will all be 0. For home direction, we will move in the reverse direction, and our homing method will be method 6. This method will move the axis in the home direction at the home high speed until the homing switch is seen. The axis will then reverse until the homing switch is no longer seen, and then will go forward in the home direction again at home low speed until it sees the switch again. Now that we have our home settings configured, we can assign the signal type for the upper and lower limit signal, which is LS nomenclature for the forward and reverse over-travel inputs, as well as the home signal input. We don't have over-travel switches in our application, but we will set our home signal to be normally closed. Now that we have finished with the homing parameter configuration, we can use XGPM to write this information to our motion controller. Now let's look at our XG5000 project. To initiate a home function, we can use one of 2 function blocks, the XPM FLT function block or the XPM ORG function block. The XPM FLT function block simply sets the current position as the home position configured in XGPM for the axis, so no axis movement will result. The XPM ORG function block is used with the parameters we set in XGPM to initiate a move to a home or origin point. Our project uses an XPM ORG for each of the axes. Let's look at the function block for axis 1. We maximize axis 1 motion program and double-click on Program. We will scroll down and find our home function block resides on line 17 of the ladder code. The function block itself is very straightforward. We will tell it which of the axes in the controller we are commanding by listing the base, slot, and axis number. It is our main PLC, so it is base 0, and if we look in the I/O parameters screen, we see that the motion controller is in slot 1, and we are homing axis 1. In our project, we are making this function block true whenever the home command is true, and the axis is ready, and there are no errors present, and the axis is not busy. Let's watch our system execute its homing sequence. Since it is a 3-axis system, we will home all 3 axes simultaneously. If we look in the Interpolation Routines program, we can scroll down to line 38 of the program and find the Home Axes comment. Here we see a function to home all 3 axes. Before we initiate any movement, it is important to note that we have functions in our project to stop motion using an XPM STP instruction, as well as reset any axis errors with an XPM RST instruction. We won't cover these functions here, but it is important to have them before executing any motion. Please also note that these instructions are not a replacement for a hardwired emergency stop. Please refer to your risk assessment to determine the safety needs for your application. Let's turn on our servos and start the homing function for all 3 axes. We see that each axis independently moves in reverse at the home high speed, finds the home switch, backs off at the home low speed, moves forward back on the switch at the home low speed, and then waits for the next command. We have now homed our 3-axis system and are ready for some motion.